Okay, let me give you a few pointers on how to work through the Landslide Lab. So we're going to focus on an event that actually occurred in California. And there's some information about it. You can go click this little PDF. It will have some imagery of kind of what occurred here. But there's been movement here. It's near the coast. I'm trying to puzzle out why it moved, do some calculations, try to collect a little data. See if we can make an argument for who's at fault, because of course that's what we like to do when there's bad things that happen to homes. And so there were homes that were built on this slope. It started to move, damage the homes. So is this a natural occurrence? Is this the result of building on the slope, or maybe some other problem? So we're going to look at a few of those things within the constraints that we can on our computer. So you can take a look at those really fast if you'd like. And then there's a map of the area that shows what's going on with some slides here. There's some roads. You can see it's kind of near the coast. You can read some of the information here. There's a little video clip that I'd like you to watch. So it's about 25-30 minutes, but you don't have to watch the whole thing. Once you load it, you'll see the slider at the bottom. This is the time frame that you want to jump to. And it talks specifically about this Portuguese Bend landslide. So you'll need to watch that so you can then answer the following questions. So make sure you watch that. Some more questions about the map. So I made it a little bigger so you could actually see it. So you're just going to answer some questions based on that map. Not too bad. Okay, so now we want to do some volume calculations about how much material was involved in this movement. So we're going to do a rough estimate here. But what we'll need to do is you'll need to download this KMZ file. So remember, can't view it or anything. You must download it. Open it in Google Earth. And then we want to try to figure out the length and the width of the slide. Because in order to get a volume, we need length, width, and thickness. Now, of course, it's a really rough estimate because it's in a regular shape. We don't want to do calculus or anything crazy like that, so we're going to assume it's kind of like a rectangle or a square. But once you open up this file here, you should see something like this. You can see the file over here. And so we're going to say that this is, some kind of little horrible, okay, maybe not a rectangle, but we just want to, the math would hold true if we could calculate the volume of this odd shape. We could still do what we're going to do. So what it's asking you to do is to measure from point to point, so a length and a width. And so you can use your little hand here. If you look down here in the bottom where the hand is placed, it'll tell you the elevation at each point. Okay, so I guess I jumped ahead. You don't need that quite yet. First, we're going to measure. Sorry, we're going to jump in here, right? Pick the right units, and then we're going to draw a point to point, just right across like that. Tell me what that is distance-wise. Clear that off, and then we'll do point to point, and then you'll have a length and a width. So if you multiply those together, you will get the area, which is what we're first looking for, right? So we're looking at it in feet, so make sure you're measuring in feet. You'll get that value there. So that's one part of the equation. Another part of the equation is how steep is the slope here. And so what data we need to evaluate that is the elevation at the top, the bottom, and the distance between the 2 points. Luckily, and it's all in feet, we already have that distance between those 2 points. Let me jump back to here. So we have this already. We just did that in the previous question. The elevation, this is what I was talking about earlier, is wherever the hand is, it tells you down here what the elevation is. So if I place it on point 2, I can get an elevation. I place it on point 1, I can get an elevation. If for some reason you're not seeing that, you're moving the hand around and it just says 0, down here in the box, you'll want to click this terrain button. If it's not checked, it won't show the elevation. So make sure that's checked, and then you should be able to get the elevations at those 2 points. Then you can get this gradient answer. Subtract the elevation from the top, from the bottom, divide by the distance. Wham, you got your gradient. Okay. Now we want to jump back. I know it's a little out of order, but we're going to jump back to that that question 9 here, right? So we have a area. If I have length, width, and thickness, now I can figure out a volume. And so this is a side view of the slide, and it's showing you some of the geology here, what rocks are involved. But this color here, this lovely green, is the slide material. So this is the slide. This whole piece moved. We're trying to calculate the volume of this. So what I need from you is a thickness here. How thick is the slide? That's my third value that I need for volume. But look, here's the scale. It is not the same thickness everywhere. So it's fairly thick here, maybe too. Over here it's pretty thin. So you want to estimate, overall what is it? It's not quite 200 because it's not that everywhere. So, keep that in mind when you're doing the thickness here, right? Maybe 150 or something like that. So you're getting that thickness, and with that area we calculated previously, and that we can then get a volume here, okay? And so some questions about how the slide might be moving, reading the descriptions of the slide, some reasons why it might be moving. And then here's one of the calculations. Here's where we're trying to use some data. So you have the entire volume of the slide, everything on the slide. There is a claim that the construction company that built Crenshaw Boulevard, that was built at the top of the slide up here, that they needed to add some material to make it flat, to make the road, and that adding that material was enough to cause the slide to fail. So one way we can evaluate that is, what percentage of the entire slide was that added material? Was it 50%? Was it 2%? You're going to calculate that. And so you're given how much cubic feet was added to the top. You know the entire weight of the top, or of the entire slide. And so we're just going to compare. You divide the added weight by the total weight, and if you multiply by 100, you'll get a percent, right? So you'll tell me the percent volume that this 30,700,000 cubic feet represents. Okay, that's what I want you to put here. What percent is it? Is it, like I said, is it 50% of the entire slide? Is it 1.2% of the entire slide? And so you'll end up putting that here and then make some maybe interpretations on what that means. Okay. Another claim was that water was really the driver here, that this is what was causing the slide to move and not Crenshaw Boulevard. And so here we're asking you to estimate the volume of water that sinks into the ground, just normally, that's natural. Okay, so we're going to do this calculation here. Those values are given to you here, and you're going to come up with a number. Okay, what we want to do is then look at how the water impacts the slide. So you're going to make some comparisons to these charts. Here's rainfall monthly. Here's rate of motion of the material, and you can see it's moved faster or slower, that kind of stuff there. Asking you questions about that little diagram. And then you make some conclusions basically based on the rainfall. And then finally, we're going to go back and look at what if there's water that's leaking from septic tanks and other things that were put in because of the homes. And so we can, just like we did with the Crenshaw, we're looking at a percentage, how much added material was put on the slide. Is that what's driving it? Well, if water's driving it, what if the people that built their homes are inputting lots of water, either on purpose or unknown to them? We're going to look at how much water is being put into the ground based on the number of homes and the approximate amount of water that might be seeping out through septic tanks and other things. So you'll do that calculation here, and you're just using this formula. You'll come up with a number here. And then same thing, we want to figure out, just like we did with Crenshaw, what's the percentage of input? So the natural amount of water that comes in is some value. Now they're adding some additional value to that. So is that 2% of the total volume? Is it 3%? Is it 50%. And so here's that calculation, right? So how much they're contributing as homeowners, how much total they get normally. What's the change? Is it a 10% increase, a 50% increase? You want to put that value here, okay? And then ask some questions about what that all means and how we might use that to figure out how to fix the problem, right? So some calculations here that are just based on, we're comparing. So it's relatively simple kind of calculations, and it doesn't explain everything for sure, but it's one way that we could use some data to either support this idea that Crenshaw Boulevard was the trigger, or maybe support that the homes that were built there, some of the factors of building the homes was the trigger, or maybe it was just a natural event that couldn't have been stopped by any of those things, right? So this is kind of what we want you to do in the lab. So just be careful of the values and the numbers. And of course, as always, if you have questions, feel free to contact me.